Okay, guys, here we go. You wanna hit Miss DeWitt? Will you grab the front light for me? Okay, then I take this off slightly. Ooh, I could be a little aggressive on that, couldn't I? All right, guys, first lesson on the new tablet. First off, does anybody have any questions from the previous day's homework? If so, I'm going to pre-5 complex zeros with polynomials. All right, so, yeah? Okay, here we go. Here's our first example. So, ladies and gentlemen, we're going to try to find our zeros. How many zeros should we have? We should have 3 total zeros, right? You guys all agree with that? Okay. So let's go through synthetic. Let's actually do the rational root theorem. So who's my p? -3. So the factors of -3 are who? Plus or minus 1 and 3, correct? Everybody agree with that? Who's my q? 1. So therefore my rational root theorem. Here are my possible roots. They are plus or minus 1 and 3. So we only have 4 choices. This one's not too shabby, huh? Everybody agree with that? Okay. So let's go through it. Here is synthetic. 1, -3, 1, -3. What do we always choose to try first? What do I always try to go first? 1, how do I do so? Add up all the coefficients. So when I add up all the coefficients, what do we get? 0, huh? So what does that mean? Do you see that? How I added them all up? 1 plus negative, nuts. That doesn't work. Okay, never mind. I was just thinking it does, but it didn't. Okay, that's okay. So we know 1's not it. Let's hurry and try our rational root, not our rational root term, but discards rule of signs. Really quickly, how many positives could there be? Okay, notice really quickly. Sorry, I'm trying this. 1, 2, 3. So I will have 3 or 1, right? So I for sure have 1 positive, and we just saw that 1 is not one of them. So who's the other? 3. Let's try it. 1 times 3 is 3. -3 plus 3 is 0. 3 times 0 is 0. Bring down the 1. 3 times 1 is 3. Get a 0. 3 is a factor. It's one of our zeros, huh? Everybody agree with that? With that being said, what is this? How do we rewrite that? X squared plus 1. Okay? Now, with that being said, ladies and gentlemen, what's the factors of 1 that get me to be 0? That both have to add to be that. It's not going to happen, huh? If we quickly set this equal to 0 and we solve, which is plus or minus what? What's the square root of negative 1 again? I. There's my other 2 zeros. I should have a total of 3 zeros, and they are 3 coming from here, I, and negative I. Huh? Sure. No problem. The only 2 people that aren't here are Alyssa and Haley. Hi, girls! Want to say hi in there to the girls that are gone. All right. Well, because they can hear me when they listen back. That's the whole goal of what we're doing here. I sure the hell hope so.
From what they've said, yes.
Okay, once again, what was those coefficients? 1, -3, 1, -3. Correct? I just want to show you guys you can actually do synthetic with imaginary numbers as well. So one of our imaginary solutions was I. Agreed? Okay, so let's go through it. 1 times I is I. What do we do there? Add them, so that's -3 plus I. And then we times, correct? -3 times I is -3I. I times I is I squared. Does anybody remember what I squared is? -1. Haley and Alyssa. Then I add those again. And then I get -3I, don't I? Does everybody see that? -3I times I. 3, what? It becomes -3I squared, but what's I squared? -3, and -3 times a -1 is 3, and I get 0. Okay, the rule is, guys, when you have imaginary solutions, they always come in what? Conjugate pairs. So notice, if I wrote this, I could write this as 0 plus I, agreed? 0 real plus an imaginary part. Okay, so what would be his conjugate pair? 0 minus I, which is just -I. Okay, I just want to talk about that, not on air. Okay, here we go. So then, -1, -I, what happens there? They cancel out, right? -I times -3 is 3I, which gives us 0. And notice, really quickly, this layer was x cubed, agreed? This layer was x squared. So this layer is x. So what's left over? X minus 3. And what's the value that makes him 0? And notice we still have 3, -I as our zeros, huh? Well, we did it this way as well, right? Where we went through and found 3. And then we noticed that after that we had x squared plus 1, and we just did algebra to find those other 2. But if they give you 1, understand that the next step is, hey, if they give me I as one of my zeros, I also know -I is. So I could do synthetic using those to find the other one. Then you don't have to guess because you've already given 2. And sometimes today they might give you a 0 to say, okay, here's 1 0, find the rest. Okay? All right, guys, ready for another one? Yes, no? By the way, if they ask you to put this in factors of linear factors or factored form, you would go like such. X minus 3, x minus I. Who does he come from? Positive I, right? And then we have x plus I, and he comes from the negative I as a 0. So that is how I would write it in factored form. Okay? Okay? We are going to find the zeros. How many total zeros? We should have 5 total zeros, correct? Now, does that mean that there's 5 individual zeros? Because once again, remembering multiplicities, 1 0, the number itself, could have multiple depending on how many powers it's raised to, correct? Like, let me just give you an example. Let me come back to this. If I had x plus 1 squared and x minus 3, notice that's a total of 3 zeros, agreed? Where this guy is just a multiplicity of 2. Somebody else? Hey! So just remember, ladies and gentlemen, what's the value of my zeros? -1 and 3 are my zeros. I should have 3 of them. Okay, I should have 3, but I only have 2. Why does that happen? Because -1 is a multiplicity of 2, isn't he? So there's 2 of them happening right there. Does that make sense to everybody? Okay. So with that being said, we should have a total of 5 zeros. The first thing I want to look at is this. What do they all have in common? An x and a 3. Thank you for combining. So when I pull that out, I'm left with x to the 4th plus 8x squared plus 16. Now, this looks like a quadratic, but it's not because this is x to the 4th. This is x squared. Does anybody remember how we could factor this? U substitution. So over here, u could be x squared. So I say, okay, this is u squared plus 8u plus 16, factors of 16 that get me to be 8, ladies and gentlemen. Factors of 16 to get me to be 8, 4 and 4, so I could have u plus 4, which is just x squared plus 4. How many of those do I have? 2 of them. Agreed? And then we're going to bring him down. There's f of x. My handwriting's pretty darn good up there, guys. Huh? Junior. Hey, buddy, it's okay. I'm impressed by myself. Okay, let's find our zeros, though, because we still haven't found them. What's the value that gives this guy? What value does he give us? 0. What about him? Well, I could come over here and say x squared plus 4 equals 0. Subtract the 4. And then square it. Remember, anytime I square root, I have to plus or minus. Okay. So I have also negative 2i and plus 2i, but a multiplicity of 2 because of him, huh? So that's 1, 2, 3, 4, 5 zeros. Yes?
So what happens because you have the x squared plus 4 squared?
Okay, so I found the zeros within here, within the x squared plus 4, which we found to be plus or minus 2i, agreed? So those are still my zeros, negative 2i and 2i. There's 2 of them, but where's the other 2 is because it's squared, they're each a multiplicity of 2. So therefore, this is 1 0. Negative 2i happens to be my second and my third. And 2i becomes my fourth and my fifth zero. You with me on that? Everybody, yes? Okay. I've enjoyed it so far. Hopefully, I haven't listened to it or things like that, so I don't know quality yet. Okay, we're going to find all the zeros. How many zeros should I have? I should have 4 total zeros. Now, we're going to do some of our theorems just to get practice with it because I guarantee they'll be asked on your test. Let's do the possible rational zeros. Can you try that for me by yourself right now? I'm going to push pause. Let's do our possible rational zero, or possible rational zeros. Who are they? Well, what's my P? Come on, guys. Negative 4. So the factors of negative 4 are 1, plus or minus, obviously. 2, 4. Who's my Q? 3. That's plus or minus 1 and 3. So my possible rational zeros are plus or minus 1, 2, 4, 1/3, 2/3, 4/3. Any questions there? They will be asking you that on your test. That's what it is, possible rational zeros. They will also ask you Descartes' rule of signs. So how many positive are there? Okay, so we can see there is 1 sign change. So we know for sure there is 1 positive. Does everybody remember that? How do we find the negative? Plug in negative x. Here's what I would get if I had negative x. I'd have 3x to the 4th plus 2x cubed minus x squared plus 12x minus 4. How many sign changes do I have? 1, 2, 3. So I should have how many negatives? 3 or 1. So that could mean, ladies and gentlemen, I have 1 positive, 1 negative. If I have that, what does that mean? 1 positive, 1 negative. Then that means I'd have 2 imaginary, because that adds up to be 4. Because I could have, once again, I could have 1 positive, 1 negative, So that's 2 of my zeros. How many zeros are there? You have a question for me? You have a question? Okay, let me hurry and finish this up and I'll come back. So I could have 1 positive, 1 negative. That leaves me with 2 more zeros. Who are they going to be? Imaginary. What else could I have? 1 positive and 3 negative and no imaginary, correct? Okay, now coming from Junior, you were asking how I got the 3 or 1, I'm guessing. Is that a correct statement? Okay. Yep. So let's go ahead and knowing this information. Yes, Brian. Okay. So did you understand how I replaced my original equation, which was this? Oops. Yes, do you understand that? So you understood where I got this equation from. So therefore, notice, does a positive from a positive, does that change? How about a positive to a negative? So that's 1 sign change. How about a negative to a positive? 2 sign change. Positive from a negative. So there's our 3. But remember, we always decrease by 2. And the reason why we decrease by 2 is because imaginaries always come in pairs. So if you had 5, you'd have 5, 3, or 1. Even positives. If I came up with 3 positives, I'd have 3 or 1 positive. Exactly. So hence why it's just 1. Great question. Great question. All right. Should we go for it? Yep. 3, -2, -1, -12, -4. That was my beginning equation. Am I correct with that? Since I don't see it up on my screen. Okay. If we add them all together, does that help? It could help us. So that means that if we plugged in a 1, what would I have? 1 comma -16. Okay. Who else should we try? You want to try 2? Let's try it. Yep, that works. Totally does. So right there, I want to show you guys something as well. Okay? This is called an upper limit. Do you guys notice? What do we notice of all those numbers that I just highlighted? They're all positive. Ladies and gentlemen, that tells you that there are no other zeros larger than 2. So even though 4 is a possibility as a 0, correct? Because there's no number changes there, it's called an upward bound. We did not do that on 3-5. I mean 3-4 when we did it. Those were questions, but I didn't get to it. It's called an upper bound. So even if it was -1 and it went straight across, pure positives, that means there's no zeros higher than that. Doesn't have to be those answers, just has to be straight across positive. Yep. Now, if it checkers, meaning it goes plus, minus, or minus, plus, minus, plus, that's called a lower bound, meaning there's no other zeros less than that. Okay? All right, so notice we went from x to the 4th down to what power now? X cubed, huh? Do you guys know I could start at this point again and do my possible rational roots again? You could. Let me just show you why. Because this is now, this is now 3x cubed plus 4x plus 7x minus 2. That time I didn't do so well. So I could do plus or minus 1, 2 over plus or minus 1, 3. And notice it just eliminated some values, huh? Such as it's 1, 2, 1/3, and 2/3. You can always go down into your smaller one and try it again so you can eliminate some values. The what? Positive 2. It could be 2 again, though. Yep, because remember multiplicities. So don't worry. Just because it happens once doesn't mean it can't happen again. So the first thing I would try again, sorry, this is a +2. The first thing I would try again is, if -1, if 1 didn't work in the first place, he's not going to work again, right? So I'm not going to try that. Anybody else want to try something? Let me show you also something you might want to think of. Do you guys see how the leading coefficient is a 3? You see how the leading coefficient's a 3? You might want to try that 1/3 or 2/3. Because somehow, some way in the factoring, you had to have a 3x there, don't you? Does that make sense? Because how do you get to a 3? Something has to be a 3 in front. So I would suggest we try, and notice we've already found our 1 positive, so we're not looking for any more positives, are we? I would try -1/3 or -2/3. Which one would you guys like to try? -1/3? I have a -1/3. I don't know if it works. Let's try it. So here's 3. -1/3 times 3 is -1. That's 3. -1/3 times 3 is 1 again. -1. That's a 6. -1/3 times 6. That's a -2. We are lucky people today. Last time, remember us trying to find that 1? We're picking nice ones today. Okay, once again, we went from x to the 4th. This one in yellow in the highlight, what is he? X cubed. He is also an upper bound, but x cubed, right? So what is 3x? That's 3 what? X to the 2nd power plus 3x plus 6. Let's see if it does factor. So the upper bound once again tells you this, Ethan. You see how all of these guys are all positive? That means there's no other number larger than 2 as a 0. Nope, because they're all positive. Felice, please. In this case. Okay, let's check. And what do these guys have all in common first? They have a 3. So that's x squared plus x plus 2. Is there anything that factors of 2 that subtract to be 1 when they're both supposed to be positive? So what do we have to do to find those? Quadratic formula or completing the square. Whatever you choose. I'm going to do quadratic formula. So here we go. X equals -b plus or minus square root of b squared minus 4ac all over 2a, which is just 2. No, because the 3's just factored out. Because if it's 3 times whatever this stuff is right here, Ethan, we're trying to find zeros. So 3 times any of these numbers that pop out will still be 0. Agreed? He's out here. I'll show you what it is in just a second. Give me a second, okay? You with me there? Okay, here we go. So this is -1 plus or minus the square root. Oops. I can't use my finger on that because it's a touch screen. 1 minus 8 all over 2, which becomes -1 plus or minus square root of -7 over 2, which is -1 plus or minus I root 7 over 2. So who are my zeros? I should be having 4 of them. Who was my first 0 that we found? 2 was. Who was the next one? 1/3. Negative a third, right? And then -1 plus I root 7 over 2. And -1 minus I root 7 over 2. There's our 4. Okay? Any questions? Once again, if they are imaginary, they will always come in what? Conjugate pairs. And is that a conjugate pair? Should make sense because it's -1 plus and -1 minus the same thing, correct? Okay, so this one, they're asking you to write an equation. Write an equation if, here's our zeros. It's degree 3. What does that mean? What does degree 3 mean? Raised to the 3rd power, meaning this is a cubic equation, okay? They are telling us our zeros are 1/2 and 3 minus I. How do I make him bigger? He's right there. Is everybody there with me? Okay, that's only 2 zeros. Did it say any of those were multiplicities? So who's the other 0 that they're kind of telling us is there, but not really? They're not giving it to us, but it's there. 3 plus I, agreed? Does everybody see where that other one comes from? Let's go ahead and write this in factored form. So if I write this in factored form, I have 2x minus 1. Does everybody see where the 2x minus 1 comes from? Okay. Then I have x minus, let's go with this 0. So we're going to subtract that 0. So what we're going to do is put parentheses and go 3 minus I. And I'm going to go x minus parentheses 3 plus I. So I have 2x minus 1, x minus 3 plus I, x minus 3 minus I. Does everybody see where I got that from? I just distributed the plus or the minus through the parentheses. Okay? Now, if you ever have imaginary numbers, multiply them first. Go ahead and multiply those two first. So we're going to have to do distributive process. So I say x times x, x squared, x times -3, -3x, x times -I, -ix. Then I go, okay, -3 times x, -3x, -3 times -3, plus 9, -3 times -I, plus 3i. Then I'm going to do I times x, which is plus ix. See how those guys cancel out? Okay. I times -3, -3i. See how those guys cancel out? That's why they're conjugates, is they will get rid of all the junk. And then I times -I, what's he? -I squared. And as you brought up, though, what is negative I squared, Junior? 1. So that is negative I squared, but that does become 1, so I'm going to do a plus 1 there. So as you can see, this is x squared minus 6x plus 10. That's what those two imaginary or complex solutions times together get. And then I have this 2x minus 1 out here. Now what do I need to do? Now I need to do what? Distribute. So I get 2x cubed minus 12x squared plus 20x. Does everybody understand where I got those? Just by distributing through the 2x. Then I'm going to distribute the negative x, the negative 1. I get negative x squared plus 7x minus 10. Oh, 6x, sorry. Is that good enough? Can you guys see that's a 6? Guess I could redo it. So what is that equation total? F of x would be 2x cubed minus 13x squared plus 26x minus 10. I put a 7, but it should have been a 6. Guys, there's something I don't think you're going to remember, so I just want to make sure. Do you guys remember difference of cubes and sum of cubes? I'm going to do a plus or a minus, and I'm just going to do the whole thing, okay? So you might see this today. So remember, this becomes a plus or minus, whatever it is. Oops, sorry. Okay. A plus or minus b. If it's a plus, it's a plus. If it's a minus, it's a minus. Does everybody understand that? And then I have a squared minus plus, meaning if this was a plus up here, this would be a minus. If this was a minus right here, it would be a plus. Would you guys like an example of what it might look like? Something like x cubed minus 8. Are those numbers both cubed? What'd you say? So this would be x minus 2. Then there'd be x squared plus 2x plus 4. So who's one of my zeros? 2. And then this guy will always be imaginary. So you'd have to go through and find the imaginary solution. Yep, through the quad. Okay? I need to go back. Okay, here it is. 3-5. We're doing. I'm going to just pick and choose through some of these. Here you go. That's the lesson.